In this lesson, we are going to look at solving problems involving combinations. In the previous lesson, you explored what a combination was, and we came up with a little bit of a formula for it. We're going to just formalize some of those thoughts. So we have what's called a combination formula, and we say that it's N choose R, so NCR. N refers to the total number of choices. So if you think back to in the exploration, where we had 5 people and we were choosing committees for a baking sale, 5 of those people was our total number of choices. The R represents the number of choices that you want. So if we wanted the committees of 2, 2 would have been our R. If we wanted a committee of 3 people, 3 would be our R. What it's equal to is it's equal to n factorial. So your total number of choices, factorial, divided by n minus r factorial times r factorial. And that should make sense. If you think back to when we did the explore, we were using n factorial over a factorial, b factorial. All right, and a, we said, was the number that we chose, and b was the number we did not choose. And that should make sense, because those two values are going to add together to give you your n. So in this case, r is the number we're choosing, and n minus r is the number we are not choosing. So that's where the formula that we developed yesterday is in this one here. We just formalize it using n's and r's. The important thing is 0 has to be less than or equal to r, which has to be less than or equal to n. So if we have 5 people, we can't choose a committee of 6 people. And we can't choose a negative amount. We can also write n choose r in brackets with the n and the r written in this format. If you see this, it means the same thing as that. It's just written differently. We're just saying n choose r, but it's being written in that form. So what we have is we've got a restaurant serves 10 flavors of ice cream. Danielle has ordered a large sundae with 3 scoops of ice cream. How many different ice cream combinations does Danielle have to choose from if she wants each scoop to be a different flavor? So we can use n choose r. N is the total number of choices. We have 10 different flavors of ice cream. R is how many we are going to choose at this time. And she wants to choose 3. So you have a button on your calculator. Wherever your NPR button was, you will find an NCR. So you're looking for an NCR button. In many cases, as I had said before, it is found in the second row of options. So you'd have to use your shift or your second function key. Or if you have a probability menu, you may find it in there. So you need to locate this particular function on your calculator. And then all you do is you type in 10 NCR3, or whatever set of keystrokes your calculator would require, and the answer is 120. If you did not have that button on your calculator, you could use the formula. We have 10 total choices. We are choosing 3 of them. That means there are 7 we are not choosing. And this will also give you 120. It is just if you have the NCR button on your calculator, it does the formula for you. So please make sure you can find that. Maybe pause the video, make sure you know how to use that button, make sure you can get 120. Next example. Tanya is the coach of a pole push team that consists of 9 players, 5 male and 4 female. In each competition, teams of 4 compete against each other to push their competitors out of a circle. The team that is successful wins. How many different 4-person teams does Tanya have to choose from for an all-male competition? So what you have to look at here, it's important. We want all male, and we're dealing with 4-person teams. So we know that this is a combination because it doesn't matter who gets chosen first. We're not picking a captain and an assistant captain, etc. We're just choosing a team of 4. So that's why we know this is a combination. All males. We only want to choose from the males. So if you look at the original question, there are 5 males on a team. So we have 5 males to choose from. We are choosing 4 of them for these teams. So 5C4, your answer would be 5. If you do not have a calculator with that button, you are doing 5 factorial over, we're choosing 4, and there's 1 extra. So 4 factorial, 1 factorial. And you would get an answer of 5. So she could make 5 different teams. Let's look at the next one here. How many different 4-person teams does Tanya have to choose from with 2 males and 2 females for a mixed competition? All right, so now we've got some cases. We want specifically 2 males and 2 females. Again, the order does not matter. It doesn't matter who gets chosen first or who gets chosen second, but we want 2 males and 2 females. So we have to do these separate. First of all, we're going to find the possibilities of choosing 2 males, and then we're going to find the possibility of choosing 2 females. And we're going to multiply those because we want them both. We want males and females. It's not an or, it's an and. There are 5 males to choose from, and we want 2 of them. There are 4 females to choose from, and we want 2 of them. So what we have now, 5C2 is 10, 4C2 is 6, so 10 times 6 is 60. So there are 60 different ways that Tanya could choose these teams. All right. A planning committee is to be formed for a school-wide Earth Day program. There are 13 volunteers, 8 teachers, and 5 students. How many ways can the principal choose a 4-person committee that has at least 1 teacher? All right, it's a committee again, so this is a combination because committees, it doesn't matter who is picked first or second. Here's something else that's important. At least 1 teacher. Whenever it says at least, we typically have cases. And so we have to find each case and then we add them all together. So what we've got is case 1 would be 1 teacher and 3 students. Case 2, at least 1 means we could have more than 1. So we could have 2 teachers, and therefore we would have 2 students. Is there another possibility? Yes, there is. We could have 3 teachers and 1 student. Is there any other possibilities? The answer is yes. We could have all teachers and no students. So now we have to find all of the possible combinations of each of these cases. So of 1 teacher, well, there were 8 teachers for us to choose from, and we're going to choose 1 of them. There were 5 students, and we're going to choose 3. So 8 choose 1 times 5 choose 3 gives us a possible 80 combinations for this particular case. Now we continue it on. There are 8 teachers to choose from. We want to choose 2 in this situation. There are 5 students. We want to choose 2. So now we find that possible combination. We get 280. 3 teachers. So we've got 8 teachers to choose from. We're going to choose 3. We have 5 students. We're only going to choose 1. Gives us, again, 280 different combinations. 4 teachers. So 8 teachers to choose from. We're choosing 4. 5 students to choose from. We're choosing 0. There are 70 possible combinations. So now what we do is we add up all of our possible combinations here. and we get 710 different ways that this committee could be formed.